I had this nice code, and I was like, yeah, this should print the same integer, right? But it actually didn't print the same integer. This is a Java code. And it's because it's a classic issue in Java where we are checking for referential equality instead of a value equality. So if we want to do it right, we need to use the actual equals method in the object. And then it works. This is a really ridiculous example, but there are many, many small things like this in the Java language. And after hitting them all at once, because that's what happened, I got a little bit obfuscated by Java. That's a long time ago. But thankfully, I had a really good mentor. And he brought the table back to me. And he told me, why don't you check this book, Effective Java? How many of you have read Effective Java here? Nice. Wonderful. What a memory. So many memories. So the good thing about Effective Java is not only allows you to work around some of the Java deficiencies or issues. It actually gives the reasons why those things work well to make good code and good APIs. And it was one of the first books that gave me a critical thinking necessary to build good software. So, this is one of my favorite books all time. Anyway, let's talk about the journey from the Java world to the Kotlin world. And let's see how actually 15 years of experience give you something on the Kotlin world, hopefully, and how effective Java actually translates to effective Kotlin. Let's get some fireworks. So my name is Ferrer Camacho, and I like slide animations, as you can see. I'm an Android developer at Mercari. I've been doing Android for quite a while now. You can follow me on Twitter. That's my handle, if you want. No worries. No hard feelings. So you have to imagine that how many of you actually work in a code base that it's 100% Kotlin? Lucky you guys. Congratulations. Enjoy life. Don't worry about this. Yeah. So for the rest of us, the problem is we've been working in Java for a long time, and we actually create a lot of tooling to avoid the classic issues in the Java language. So for now, it's a little bit difficult for us to migrate all of these things because we already have all these libraries, static analysis that help us to use Java without thinking too much in some of the issues. So we need to live with Java 2 for some time. And we don't have a strong reason to actually be super strict about using Kotlin. Because, let's think about it. Kotlin beta 1 was in 2015, so it's not a long time ago. Java has been there forever. Like literally, I was a kid. Yeah, that's Java. And then, so in 2017 was when Google actually announced that the company was supporting Kotlin as a first party language. So anyway, this was my friend for a long time when I was doing Kotlin. I went to the bytecode, and then in the same place, you can decompile and see how it translates to Java. So I was able to leverage the Java knowledge and help me to get into Kotlin. So I recommend you to actually do Command-Shift-8 and search for this and have it there always when you have some issues or you don't know exactly what Kotlin is doing under the hood. So this is your friend forever. OK, let's get into effective Java. How do the items in the book translate to actual Kotlin? There are actually many of them that are obsolete now, which is great. We don't need to remember more things. We can actually focus on delivering features. I'm going to just check the ones that I'm more excited about and that makes my life and hopefully your life easier. So for example, the item number 3 is enforce the singleton property with a private blah, blah, blah. This is how you should implement singletons. The thing is, singletons are so common that why do we even need to re-implement them every time? And why do we actually need to invest time on thinking, how do I implement it properly? So this is the effective Java solution. Just use enum, because enum gives you, it's serializable and thread safe, so that's good. It has some issues. It's not lazy loaded, so it runs in memory right away. But the Kotlin creators were smart enough to say, let's just create a keyword call object, and that's a singleton implementation. So developers don't need to actually have discussions on how to re-implement over and over singleton. And then if you go to the decompiled Java that Kotlin generates, which is the one in the bottom, it's actually a lazy loaded singleton implementation, where there is a static block, and that static block, it's only going to be loaded one time whenever you need that singleton. So this is great. We don't have to think about this anymore. Forget about this. Item 2. Consider a builder when faced with many constructor parameters. I love the items. They are so poetic. So there is imagine this is a common scenario in Java. We have this Pojo class where we want to store data from network or from the screen. So imagine we have this item, and there is ID, name, and description. And then you want to do it nice. You want to use a builder because the builder, you can put names on the method, and that's great because it's more readable, it's more maintainable, and it allows you to check each time if they are required, not required, things like that. But you have to do this all the time, many, many times, and for many different classes in the code base. So it's only 12 lines, but imagine if you multiply for many of them. Why just not using like what Kotlin did, which is like you have required parameters and optional parameters, and then that's it. And you can use JVM overload, so you generate for Java 1 to n constructors, and then you can do something like this. Or you can actually use name arguments. So this is actually the same idea as a builder. Like you are naming the parameter you want to set. Because the problem here is if you have all the fields with similar types, you're going to end up swapping them because we are humans and we make mistakes. Especially I make a lot of mistakes. So that's why the builder was really useful for me. But with this, I don't need to write the builder myself, and I can use name arguments or just default parameters. So this is, again, some code that Kotlin does for you, so no error prone anymore. So let's talk about the item 40. Consistently use the override annotation. This is really fun. We don't do this. We just forget because, listen, our goal in life is to compile code. We don't care about the code that is showing in the phone. We just want to compile and say, hey, it's done. I'm good. I'm leaving now. Bye. I'm not leaving, sorry. So this doesn't force you anything. You forget the override. You're implementing the inflate, but you're forgetting the override. And you're like, cool, it compiles, so I don't care about the override. Somebody will figure it out later. But the good thing about Kotlin is that it actually doesn't compile, so it forces you to fix it because we always want to compile things. We love to compile things, in this case, in our world. So this is fantastic. This item is obsolete now. We don't need to care because the compile is actually is going to force us to fix it right away. So this is great for actually maintainability and readability, of course. Please don't ignore the override. Well, you can't ignore it now. So thanks to Kotlin, this is better. Let's talk about item 17, design for inheritance or else prohibit. This is another beautiful thing where in Kotlin, if you try to do that, by default, it's going to be, nope, not going to happen. It forces you to actually make the decision in place, hey, are you sure you want to do this? Because it's like a bad idea, effective Java book. This is what Kotlin is telling to you. Effective Java book told us that this was not a good idea for many reasons. Are you sure you want to do this? He's asking you, do you 100% sure about this? And you're like, I want to think about it. And that's the whole point of this being closed by default, the classes being closed by default. It makes you think and actually force you to make decision on site. So, because what happens on the other way around in Java is by default we don't do final, and then at some point it's too late to make it final. So with this, you actually need to make it explicit with the open keyword, and then this is okay. But remember, not do this. Instead, favor composition over inheritance, because that's easier for, you can replace implementation, you can test easily, you can do many things when you actually follow this item 18. So the good thing about Kotlin is that it makes it easier for you. So of course, why not? Let's use the nobody understands coffee machine example from Dagger and all the other dependency injection frameworks. Why not? I actually really like espresso, so this is we are building here a really expensive espresso machine, okay? So we have, for a machine to work, you need the boiler to heat the water, right? And then you need the pump to actually move the water to the boiler. And then if it's a dual boiler or double boiler, it's great, because then you can make a coffee and heat the milk at the same time. This is the espresso machine you want. And then, because then you can do multiple at home for the family at the same time, really fast, really performance. And then rotatory bean is like a gold bean. It's fantastic, really good coffee, gonna go out of there. Anyway, doesn't matter. So imagine we wanna build an espresso coffee machine in Java for some reason. I don't know, nobody cares about this. But you need to implement those interfaces, and then you need to build the code to inject those things into the constructor. Or maybe you're gonna use Dagger. Dagger is great. It just comes with a lot of DSL that you need to learn, and everybody needs to learn, or otherwise there is gonna be people saying like, it doesn't work for me, how do I fix this? And because this is difficult, listen, it's difficult, Dagger, unless you work in Dagger. So anyway, if you do it manually, this is the manual way to do it, which doesn't scale, right? When you have like 20 of those, it doesn't scale that well. But thankfully, Kotlin, we have the delegate, and then you can do, okay, this espresso machine, it's implementing boiler, and it's delegating on the implementation dual boiler, and the PAM is the rotatory bean. And this is already doing all the things that you used to do manually in Java. If you go to the decompile code, this is what it actually generates. It actually generates, well, in this case, they were, I did a trick, they were actually singletons. But if it wasn't singleton, it will be injected by the constructor. So it does everything for you, Kotlin, just by using the keyword by. This is fantastic again. This makes me happy. The more code I write, the more features I create, not just rite of passage around Java things. So this makes me happy again. This is item 77. Don't ignore exceptions. But we all ignore exceptions. I do it too. Sorry, guys, I do it. Because, seriously, what do I do with this exception? So I'm trying to close, and it says that I can't close it. So what do I do? What do we do at that point? I don't know. Just ignore it. So anyway, yeah, there are check exceptions in Java. But they don't work so well, actually, with functional programming. So most of the functional programming languages decide to not have check exceptions. And actually, Kotlin did the same. Kotlin doesn't force you to check to try catch any exception. But if you want to do it, the cool thing about try and catch in Kotlin is that it's actually an expression, and you can return values from that expression. So it's actually super readable, right? It's like, okay, let's cast this value into an int. If there's an exception, just return -1, which we know is like an error or something. And this is super readable. It's, try and then catch and then return this. Cool. So it's, don't force you to catch weird exceptions. And sometimes exceptions are legit. So please catch them when they are legit. But sometimes you don't know what to do with them, so just don't need to do it. And you can use try and catch as an expression. So this item is actually improved in the Kotlin language too. Which, again, I like it because it forces me to think less about issues with the language and more about the features that I'm building. Then there is this item 15, which is minimize mutability. Please do this. But then when you do this in Java, then you need to obey the contract when overriding equals. And then because you override equals, you need to override hash code. And it's like a never-ending story. It's terrible. So you have this, again, the Pojo. The name is item Java because it's Java, of course. And we have ID, name, and description. And they are immutable, fields. So what you need to do is constructor like this, where you're checking if they are not null because they need to be not null, and then you are assigning to them, but then you need to override equals because effective Java says so, and you need to do it, otherwise the equals won't work, so you need to do this. And there's more lines, and if it's the same reference, it's fine. If it's not, is this the instance? If it's the instance, then let's check all of them. Oof, too much thinking into use those things. So then remember, hash code. Don't forget the hash code. You need to multiply by a prime number and then do a summatory of all the fields, blah, blah, blah. Yeah, because you want to have only one equals need to have the same hash code between them. So that's the contract you are trying to do. And you need to do this every single time you want to do one of these immutable classes for data classes. It's crazy. So it's like 100-something lines for nothing. No feature. This is no feature. This is just holding a state. Data, sorry, not a state. And then you go to Kotlin, and this is wonderful. This is just one keyword. What is happening? Why have I been doing this for 15 years? I mean, sorry, not 15 years. There is many libraries that do that for you, but they still they do have a little bit of boilerplate, like auto value, for example. But this is just beautiful. It's amazing. It's really powerful, really effective. One keyword gives you let's decompile this. If you decompile it, you get all of this for free. All of this for free. No error prone, no human errors. I make a lot of errors, so I need to triple check all my code and do 3 unit tests for all of them because it's really, I'm a human, sorry. So, it creates for you the constructor, all the getters, and it keeps creating things for you, the equals, the hash code, but it creates more things. It's great. Copy. Because when you have an immutable data and you want to modify some of the fields, you need to copy the same, at the same time you are creating the new one, modify the one that you actually want to be different. And it does the toString. toString is actually other of the effective Java items that I ignore. But yeah, this is good for debugging. So they generate that toString for you so you can debug really easily. But there is more. Wait for it. This is great. It's super cheap. One keyboard, and you get you're deconstructing the class into all of the fields so you can do really readable code where you can actually, this is classic, you get a data class and you need to process many fields of it, right? So by doing the deconstruction of the data class, you can actually do that in one line, and it's pretty clear to me that the ID, the name, and description, they come from this foo item, which I'm creating on the method below. And that's thank you to the data classes creating the component 1, 2, 3, and n, depending on the fields. So again, one keyboard, 180 lines of code for you, 0 error prone, no human error involved here. But there is more things, right? So if you do Android, we do Android. So parcelable is one of those beautiful things where you need to actually implement a contract, but if you do it wrong, you don't even realize actually. It's like you realize in runtime, maybe. Sometimes you don't even realize because you get default values. So unless you are checking for something really specific, the error may come really late on the execution, so you can never actually tie it to that error on the implementation of parcelable. So by using the annotation parcelize, you can, the Android Kotlin plugin actually generates a parcelable code for you. This is great. There's more free things for one annotation. I love free things. It's good. And again, if you give me 5 minutes to override equals and 5 minutes to create a beautiful UI, I will take the 5 minutes for beautiful UI always. I will actually introduce the bug on the equals. I don't care about the equals. No, I'm just kidding. Kotlin gives it to you. So that's why this is wonderful. And as you can see, there is a common pattern here that it seems the Kotlin creators got really interested in effective Java and actually add many things into the language, in the core of the language. So that's great for us, actually. That's fantastic for us. So again, 120 lines for one keyboard. Great performance. Oh, no sound. So close. Well, he is Sir Tony Hoare, and he was the inventor of null pointer references. And in these 30 seconds that you cannot hear, he is ending the sentence by saying, well, perhaps it was $1 billion mistake. Yes, sir. It was a wonderful $1 billion mistake. And we all remember about this forever. So yeah, in Java, how many of you get null pointer exceptions every day? Right? This is beautiful. It's great. So in actually effective Java, there are many items that are all about how to handle null values. And the classic one is item 43, which is if you're returning a collection and it's empty, don't return a null, return an empty collection, please. So we avoid some null pointer exceptions. But let's talk about the elephant in the room, which is how do we handle null reference in Java and how that changes in Kotlin. You all know about this, but I want to make a clear example of what happened to me or what happened when you work in a team with many people, remote, and that there is a lot of code going on, and you need to do many code reviews a day. Most of the time, I get this line of code in the code review. So if you get this signature of the method, you don't have any information about the nullability of the parameter or the return value. So if you're doing a code review through a tool that doesn't have a static analysis jobs, then you actually need to download the code, which you're going to do anyway, hopefully, and run to avoid bugs. But it's difficult for me because I don't know what's happening. Imagine even if that comes from a third-party API where I don't have the code. I cannot read the code. So I can't trust them what is happening. So I always have to check defensively against null. So I get this spaghetti code where if, all the if. There is more if than actually feature code. It's great. So usually, when you're doing the code review, it's the classic, okay, are they adding the nullability? This is in Java. Are they adding the nullability annotation? Are they actually favoring optionals or empty values rather than null? If it's a null, is that null a possible value, or it's just because they forgot that they should use the optional or the empty value of that class? If it's a null, a not possible value, maybe you want to throw an exception for that too, because it's an legal argument, right? So the code review is not about the actual feature code. It's about, okay, let's handle null pointer exceptions now, okay? It's a code review about null pointers now. And this happens for all the reviews. And then you try to do some nice things like this contract where I'm telling you not null and not null, but they don't enforce it. It's just like, this is our understanding. I'm reading your code and you're telling me, and I trust you because you work with me, but I want to see some unit tests just in case, Let's do some unit tests just in case to enforce that. And then, you get an ID. You don't get a compile. I told you, the most important thing is to compile. This allows you to compile, but this is going to crash. We don't want this. But we ignore ID warnings. Yeah, we like to live on the edge, and we do these things. So that's the problem. We are using this, but this is not enforcing anything, actually. So this line in Kotlin tells you exactly the nullability of return value and parameter. And that's a different. My brain changes when I see Kotlin code. I don't have to care about this anymore because the compiler is going to check it for me. This means that by default it's not null. And if you want to make it null, you need to use your brain power and say, is this going to be null? Do I really want this to be null? And if I want, I need to actually write an extra character, so it's expensive for me, extra character. And it's a question mark, so it's like, wait, is this the right value? Okay, anyway. So, and the wonderful thing is when you go to the Java code that decompiles from this, it's actually the same not null, but of course, they check the values before running the code of the function. And if you are when you are doing interoperability between Java and Kotlin, Java doesn't ensure that, so you can always pass a null, but it's gonna fail in runtime, so that's good. I at least know that we are gonna fail fast. So that's why I was saying before, you should download the code and run it just in case. Especially if you play with Java, if you have Java and Kotlin code together. But this is just fantastic. I do this, and I get the same, but at the same time, it doesn't compile, so I'm good. It's like, cool, doesn't compile. So I just the first thing, my goal in life is to compile things, so I want to fix this issue. I want to be sure that I'm not passing a null, because otherwise I cannot compile my code. And that makes me happy. Emojis. Anyway, let's talk about idioms. There is a half of a chapter in Effective Java about idioms. All of those things, which are pretty much, instead of using primitives for predefined constants, just use idioms, right? Any type of idioms. So you can keep using those, most of them in Kotlin. But I want to talk about something more powerful. They're called seal classes, and they represent restricted class hierarchies. They are so powerful that they have some heavy weight there. So the good thing about seal classes is that it allows you to represent abstract data types, and with that you can imagine you have the classic presenter with a state, so you could represent all the states of that screen with a seal class, and it will be like a finite state machine. So that's why I like seal classes. It gives you more powerful. We could not do this without a lot of boilerplate in Java. So, for example, we have this remote data class, seal class in Mercari at the code base. It's an open source project, actually. It represents any network request. So any network request states, right? So for example, what is the classic first state? Not even initialized. It's just like waiting for something to be executed. And it's a class, but it could be actually an object because it's a singleton, right? Because not initialized means the same for all the network requests. It doesn't need anything specific to for a different network request. And then you have the class loading, right? This is the other state. You are loading. You are actually making the request, and you are waiting to get all the data. And that actually could be a data class because it's going to have some value. You're going to have a progress that you probably want to update the UI when you get a new progress, right? And then the classic two results of a network request is either success or either failure. And if it's success, you want to get the response so you can parse the data. And then if it's a failure, you want to get exception, and you want to react depending on the exception you're getting. And so this is different to an enum, right? You see that I can have any type of class inside the seal class, which is not possible with enums. And so this allows me to represent all these states. And when using that, pairing it with the when state, then is when we can have fun. So when we use the when as a statement, then as an expression, then we get compile check exhaustive, sorry, English is difficult. Compile check exhaust. Pretty much, the compiler is going to check that you are actually consuming all the values inside the seal class. That's better. So that means that if I modify remote data, and I add a new state, all the places where I'm using this remote data in a when statement, I'm going to be forced by the compiler to add the new branch in that restricted class hierarchy. And that's really powerful because this is a classic where you have some state and you forget to catch the state. Like if you do this manually in Java, in your presenter, you're going to add a new state. And unless you are the same person that wrote that presenter, you're going to probably forget some place where we need to actually modify something. This is really classic. With seal classes, you will get a compiler and you will be forced to update all of them. So for example, when we get the request and it's not initialized, we just want a request to execute. When it's loading, we actually want to update the view model and say, hey, it's loading, this is the percentage, please update the UI. When it's success, we want to do the same but transforming. The transformation is from the request, I'm going to get the data that I really want, and the UI will be updated with this. And the same for the failure, right? When there is an error, we want to show to the user some error that means something for them, because I don't want to, if I'm a user, I don't want to see error 52346, because I don't know what I don't even know what was it. But I don't understand, so you need to tell them, like, for this error, this is the text that it's relevant for the user. Anyway, with this, if I remove or add a new class to the remote data, I will be forced by the compiler to add it as one more branch. Unless you have else. If you have else, then you defeat the purpose of this. But you can have it, that's fine. So if you want to check more, the code is actually more extensive, and you have some extension functions that are really classic, like you always need to transform the response into something. So we have that extension function. So please check it out. And Kitty was actually the person who did most of the heavy lifting there. I think it's a really interesting, a small project, open source project, where you can see the power of seal classes. And now let's talk about generics. Ta-da. There is actually one chapter only about generics in effective Java, because they are complicated, actually. It took me many, many years to understand anything, especially the wildcards. We'll talk later about this. So favorite generic methods. We have this thing in Kotlin called refi. That is wonderful, and you cannot do this in Java. So given an inline function, actually inline extension function for the context, you can use the type of T inside that block. So that means that you can do something like this, right? So you can only pair refi with inline. And the reason to do that is because the color, inline means that, sorry, let's go through this. So because we have inline and refi, we can use the T class there, so it's going to start an activity like this, right? So we cannot do this in Java. If we try to do this in Java, it will be to pass actually the class as a parameter, right? Because in Java, we cannot use the type generic inside the function because the type erasure, right? But the way inline functions work, they get replaced by the compiler on the color side. So by type inference, the Kotlin compiler actually knows the type T and can replace T by the actual type inferenced T. So that's why this works, and this is pretty unique and pretty great. And it helps you to have better APIs, right? Like, there's so many. Actually, Android X Kotlin extensions, right? They modify some of the most difficult and weird Android APIs by using many of these type of reified functions. And you can check it out, it's open source, and it's a really good way to see how it helps you to get better APIs. So this is powerful, and you can only do it with Kotlin, not with Java right now. There is the item 28, which is, we're keeping talking about generics. Prefer list to arrays, right? And this makes sense for Java, because arrays are covariant. We are getting into the variance show, and this is a really interesting show. So we have integer, which is like a subtype of number. So if you have arrays, you can do this nice thing, which is, well, not nice, but you can do this thing, which is assign an integer array into a number array, and then you can assign in the first cell, you can assign a long value into that. But that makes no sense, because a long is not an integer, so it should actually never compile. But because it's covariant, means that the integer is a subtype of number, but then array of integer is a subtype of array of number 2, and this is the show. And then what happens is you compile, you're happy, and then in runtime it's like, nope, not working. So that's why effective Java tells you, please use list, don't use this. Because list is actually invariant. So that means that you can never assign a list of integer into a list of numbers. And then you are not going to have this type of issues. It's going to actually enforce the type safety on compile time. We only want, compile nice and neat. So when we enforce things on compile time, we know that we are going to be forced to fix them. So this is really important. That's why effective Java recommends to use list instead of arrays, and some other things too. But arrays in Kotlin are actually invariant too, and allow generics too. So you can just use arrays in Kotlin too, and it's fine. It's going to work as good as list in Java. This is what it does. Then this is the item 3.1, which is a really difficult one, because use bounded wildcards to increase the API flexibility. The fact that it's a wild thing, this is difficult for me. It's like, wow, so wild. Anyway, let's talk about this. Let's get this straight. So the effective Java has this example, a stack of E, right? And you want to push all, and you get an iterable of E. This doesn't work. This doesn't work when you have a stack of number and you are trying to push an integer. It should work though, because they are subtypes, so it could be perfectly inside there. So it doesn't work because the parameterized types are invariant, right? So similar to what we were talking before. And so how do we fix this, right? That's the question. That's exactly how you fix it. We don't know how to fix it, so we put this. It's a question, extends T or E, or question, super T. And this is the wildcards. And don't take this from me. Just go to Java documentation, and there is a link that says, wildcards, probably one of the most difficult features in Java. And that's true. That's in the documentation. So Joshua Block came up with this, because what does it mean that extends from T? And what does it mean that is super of T? Well, this is what it means. He created PEX, which stands for Producer Extends, Consumer Super. Not great, but it works. Producer Extends, Consumer Super. Okay. So that means we were not able to do this, but we can do this if we replace the E with what this iterable is doing. This iterable is actually producing is. It's producing is, and we are going to add them into the stack. So we just do that. We just do, producer extends. So we are doing producer extends. And this suddenly, magically works. It's wild. It's fine, sorry, it's a bad joke. So you can do the same with the pople, right? The pople means that we are going to add to the destination collection all the items in the stack. So it's going to be consume super. Okay, consume, it's not good, but it's better than nothing, because wildcards are difficult. This is called use site variance. And it's called use site because it's it's used in the place where you are using the type, right? And Kotlin has the same. So we can do the same. But in my opinion, it's more readable and more understandable, because they replace the question mark extends and the question mark super, wildcard, by out and in. And out produces things, and in consumes things. That's more like natural to me. Out produces, in consumes, right? Or consumer in, producer out. Consumer in, producer out. Cool. This is more readable for me. I don't have to remember. There is less characters to write to, the wild kind of thing. So in my opinion, use side variance is better in Kotlin and more readable and nicer. But then Kotlin has this declaration side variance, which is available in some other languages, which is really interesting too, because it gets annotated in the class or in the interface, and it's a clear contract from the side of the implementer. So if I have to implement source, I know that it's only going to produce T. If I'm writing interface, what I want the implementer of this interface know is that only produce T or it's not going to work. That's what I'm saying right here, right? The same within. Within I'm saying I'm only consume T, so please, when you implement this, follow this, right? And again, it's really easy to read out, in, right? And it's more helpful because it allows if you are sharing code with people, when they see the interface declaration, you see it right away. But moreover, IntelliJ actually gives you that for free. If you enable it, it will tell you when your interface or class can actually have declaration side variance. So this is great. IntelliJ will do it for you. You don't have to think about it. So these are generics. They're beautiful. They're great. They're different, a little bit different, but in my opinion, the really interesting part is that you use in and out, which are more readable, and then at the same time, you have the declaration side variance, which we never had before in Java. They are actually discussing now to have it, but we know how Java goes. So, as I showed during the talk, Kotlin is really opinionated and brings many of the effective Java items into the language core. Actually, if you check effective Java now, probably it's going to be like a really small book. It's a really big book, but with Kotlin, you are only going to be able to use some of them because they are already most of them in the language. And what I really like about Kotlin is that they decided to make clear things by, for example, when you have to define a variable, you need to actually decide there. You need to use your brain and decide, is this going to be a val or this is going to be a bar? And they have both different intentions, so you need to be sure that you're making the right decision. You can change it later, but that propagates down to your implementation, right? But it's great that you actually need to think before. And the same with null and non-null. By default, it's not null because we don't want to have null pointer exceptions, so we should actually try to minimize nulls, but sometimes nulls are a possible value. But then you're making the conscious decision by adding the question mark, right? So this is a thing that I really like about Kotlin, that they create these extra keywords that make more clear what you are trying to design here. Not only that, but Kotlin brings some fluency, right? It brings the joy of functional programming, right? Because, you can do that now, most of it with Java, but we were stuck for a long time before. We were stuck for a long time in 5 and 6 Java, right? And so that was not the case for Android developers. But you can do things like that where you get an array and then you make it a sequence and then you can filter and map and do all the nice things about functional programming. And then if you want to get even fancier, you can use Arrow, which is like taking a lot of ideas from Scala, from the Scala world with monads and options and tries and evals and many more functional programming goodies, and they keep working on it. So this is definitely like even more fancy functional programming than what Kotlin gives to you by default. And at the end of the day, it's more about less boilerplate and more features, right? It's fluent, it's more readable, and then I don't have to write so much boilerplate because the language is already thinking about me, how to make things faster and better. Not only that, but it comes with IntelliJ, which they are the same people, so of course it pairs really well together, and it keeps giving you goodies like the fact that they can infer if you need to put in and out, for example, in classes. That's a really nice thing to have. Then we have lambdas expression. Well, this is nothing special. It's markups, string templates, typing friends. Type alias, I like type alias. Type alias are great when, remember when I was telling at the beginning of the talk about we always make mistakes if we have the same parameter types. With type alias, you can still use the same type parameter, but saying type alias ID equal string. And then suddenly the ID is an ID type. But still, underlying type is a string. But you can never swap now description with ID anymore because they are different types. So that's type alias. That's great. Then the rich expressions that I showed in the slide before. You can overload the operators, which is great, companion objects, coroutines, which is interesting. We'll see where it goes. It's a different threading model. So I actually want to talk about coroutines because there is a whole chapter about threading in effective Java, and I wanted to compare it with coroutines. But that actually took 2 hours, so I was like, no, I don't think we are going to have time to do this, so maybe another talk. And then I really like contracts. The fact that we can override the compiler decision to say, no, I know more than you. Let me do this. I get this. And this is coming now. And inline classes is coming now too. They keep just bringing more goodies and more interesting things that are going to make our development much easier and productive and effective. So I guess the question is why we are still using Java. And again, I want actually to pay a tribute to Java because so Java is not going anywhere actually. It's actually most of the backends are having written in Java, and they're going to be, I think, still for many years be in Java because Java has a big tooling, big libraries that work really, really well. And there is no actual incentive for you as a company to replace something that works for you, even if developers know, I like better this language, it makes me happy. Well, happiness, it's not measurable with money, so the company's going to be, well, this is a really difficult system. Why are we going to replace it with a Kotlin when it has 3 years old language? And so it's going to be around. So don't forget about Java, and Java is great. Because of effective Java and Java, we were able to see how Kotlin learned from that and how we are all learning from that too. So I'm expecting soon that we have an effective Kotlin book because I guess we need to start getting effective Kotlin practices because there are a lot of things that can go wrong in Kotlin too. But I guess I want to empower everybody to use Kotlin because it's really a joy of a language, and keep pushing in your companies to use Kotlin. And thank you for coming. I hope you learned something and you like the talk, and see you around.